Hello, my third grade friends. Welcome back. This is Mrs. Smith here, and today we're doing Unit 1, Lesson 10. And this starts on page 45 of your book. So, we're exploring some patterns with threes today. Now, threes are not as convenient, in my opinion, as twos, fives, and tens because the number that is in the ones place of all the different products of three, there's not like a super solid pattern, like it's not like they all end with 3, 6, and 9. It's like 3, 6, 9, and then 2, 5, 8, and then 1, 4, 7, and then 0. So it's really helpful to just count on by 3 from ones that you do remember. Like you probably remember your 2, your 5, and your 10, maybe your 9 if you like those fun little finger tricks, and then you can count backwards or count up because it's not super patterny like the other ones are. If you do notice a pattern, you can send me an email or something, and I'll be happy to add it next time I teach this lesson. Okay, so like I said before, sometimes it's helpful just to use your other points of reference, like your 5s, your 2s, your 10s, maybe your 9s, to find those in-betweeners. And that's what we're going to practice right here. So we are using what's called the 5 shortcut. So doing, like in this first one, it's 8 triangles. So here's the 5, and then here's 3 more. So even without writing all these down, which we're going to do later, we're not going to write them all down, you can know if each triangle has 3 sides, this is 3, plus 3 more is 6, plus 3 more is 9, plus 3 more is 12, and plus 3 more is 15. Now you could also just memorize 3 times 5 is 15 and then add it on from that point. 3 more, 18, 3 more, 21, and 3 more, 24. And so 8 times 3 is 24. On tricycles, so 6 tricycles, so it's 3, 6, 9, 12, and then 15 for that 5th one. And then over here, 3 more from there is that 18. Right? A tricycle has 3 wheels. 7 tripods. Well, we know that first 5, 3, 6, 9, 12, 15. And then adding 2 more groups of 3, 18, and 21. So 3 times 7 is 21. Now here we're going to keep using that shortcut. We're going to skip writing the 3, 6, 9, 12. We're just going to say, okay, that group of 5 things that have 3 each is 15. And then from there, we're adding on 6 more, 21. This is 8. Then from here, our 9 tricycles, what is 3 times 9? Well, you might not know that already, but 3 times 5, 15. And then 18, 21, 24, 27. 3 times 5 is still 15. And then right here, 18, 21, 24. Okay, so just using that 15 as a starting point so you don't have to spend so much time on the in-betweens. All right. Now we're going to write some equations and solve the problems. If you would like to use your whiteboard and draw pictures, you're welcome to do so. I will do that for some of them, I think. Spencer arranged his soccer trophies in 3 equal rows. If he has 12 trophies, how many trophies are in each row? So let's visualize that for a moment. We got 3 rows, boom, boom, boom. We got 12 trophies evenly arranged. So I'm just going to count out 12 and put 1 on each row until I'm done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what I did there was I had 12 and I divided it by 3, and now how many are on each shelf? 1, 2, 3, 4. 4 trophies. Number 8. How many sides do 8 triangles have all together? Go ahead and give that one a shot on your own. I think you can do it. Okay, you ready? If you're not ready, pause it and then play when you're ready. So this is 8 triangles, each with 3 sides. Is how many? We just did that over here, right? Which one was 8? 8 tripods, 24. These are 15, 18, 21, 24. 24 sides. Okay. For Sophie's class picture, the students stood in 3 rows with 5 students on each row. How many students were in the picture? So we have 3 groups, each with 5, and we're looking for the total. So that would be what as your equation? 3 times 5. Let's go ahead and not count by 3s, but let's count by 5s because of that commutative property of multiplication, right? 5, 10, 15. How many was it? 15 students. Okay. Tickets to the school play cost $3 each. Mr. Cortez spent $27 on tickets. How many tickets did he buy? Now, I was looking at this, and I'm sure you were too, and I learned that 10 times 3 was 30. 27 is so close to 30, right? It's in fact 3 less than 30. So rather than being 10 groups of 3, it's 9 groups of 3. So 27 divided by 3 equals 9 tickets. Jess solved 21 multiplication problems. If the problems were arranged in rows of 3, how many rows did Jess solve? So this is really saying what times 3 equals 21, or 21 divided by 3 equals something, right? So then we can use our 15 as a count or like a starting point for counting. So 15 is 5 plus 3 more, so 6 groups of 3 is 18. And then another group of 3 from 18, so 18, 21. 7 groups of 3 is 21. 7 rows. Alrighty, last one here. Last year, 6 sets of triplets were born at Watertown Hospital. During this time, how many triples, I think they mean to say triplets, were born at the hospital in all? So 6 groups of 3. How many? Well, 15 is 5 groups of 3. So one more group of 3. 15, 16, 17, 18 is 18. 18 triplets. All right. Go and see if you have an assignment, and I will catch you next time. Nice job, everybody. Bye-bye.